Hello everyone. Today is the day 8 of doing competitive programming. So let's open our terminal and start our timer of 60 minutes. Yesterday we have solved a few questions. Today we'll be solving few more from the codechef. We have seen the questions based on the rating, right? Arrays concept from yesterday's video. Now we'll try finishing these questions in which you need to have a TLE. So Kmax is the question. We have seen the question and then we change our mind to solve based on the rating. So today we'll be solving kmax.cpp. Let's just close this. Okay, now let's read the question first. You're given an array containing n integers. Find if it is possible to choose exactly m elements from the array such that a mix of the chosen elements is exactly k. And here they are explaining what is mix actually. Mix of an array is the smallest non-negative integer that does not belong to the array. For example, the mix of 2 to 1 is 0 because 0 does not belong to the array. The mix of 3 1 0 1 is 2 because 0 and 1 belong to the array but 2 does not. Okay, that's what they are saying about the mix. The first line containing an integer t. Okay, now they are giving our inputs an mk and an array. So let's just use our snippet array and we got our array reading it. N, k, n, m and k are the values they are giving. Doesn't matter the order is not important. You can read it n, m, k or k, n, m. Initialize however you want. Anyways, now we need to print yes if it is possible to choose m elements from the array. So the mix of the chosen element is exactly k and no otherwise. And the output is not case sensitive. You can put it print any of these things and the output will be same. Firstly, we need to we'll see the test cases. Here are the okay, fine. Actually, I was thinking to solve this or not to solve the array, or is the position is important or not. Anyways, now let's just see the test cases. They are given n equal to 5, m equal to 4 and k equal to 2, and there is 0 1 3 0 3. So now they want k as equal to 2. Yeah, we can choose in this array, we can choose this thing and we'll get the max 2 because 2 is missing here. That's it, right? I think in such type of questions there is one possibility, if it is possible to use m elements from the array so that the mix of okay. If it is one possibility, then we can print s. If there are 0 probable, then itself we need to print o. So we can print s here. And the next question, k is still 2 but m is 1. Now the point is that is the 0 1. You need to choose one size of one element where k whose max should be 2. Here if you choose only 0, the max is 1, and if you choose only 1, then max is 0 because the minimum non-negative element, right? So we have will be printing no, or else can we generalize it saying that because if k is greater than m, there is no possible. If you choose 2, if the array has 2 also, or if it has 3 also. If we choose only 3, the max will be 0, because minimum non-negative. 0 is minimum and is not present in the array. So that means if it is 2k, minimum should be 3 to get the x2. So we can say that if I guess we can take this point. The point is, if m is k is greater than m, we'll say no. Okay, that is for the test case 2, and the third case is 333 Here, yes, you can get 3. You can select all the 3 elements. Next, 433, you got 2043. I guess if you select 204, the max is 1. Yeah, if you select 203, you cannot get a max because 3 is included in the array. There is no possibility. Can we conclude anything from here? Okay, let's just see 542. We have 1, 0, 2, 2, 5. We need to select 4 elements. We cannot select because 2 and 2 are already present. So we need to remove these 2 elements. If we remove them, then the size of the M is 3. And if it is 3, which is less than 4, then we cannot take a subset, so it is no. And for this 652, we got 1, 2, 3. Okay, we need to remove 2. If we remove, then we got 0, 1, 0, 0, 3. So it is yes. So shall we remove all these things? Yeah, let's just remove them. We need to remove one point, that if k is greater than m, then we'll directly print. Let's just say if k is greater than m, and we'll write cout no, and we'll just return. Okay, that's the point we have taken. And if any element less than yeah, that's what is happening here, right? That element will be the max. If k is 3, then if the array doesn't contain element less than if it doesn't contain element less than 3, then we cannot we cannot get 3 because 1 is missing. So 1 will be the minimum. We cannot include 1 into the array, in simple words, because 1 is not in the given array itself. So let's just take shall we sort the array? If we sort it out, is that a problem for us? Because the positions will be gone. I don't think it's a problem, so we'll just say a comma a plus n, and after sorting, if we'll take a for loop, d equal to 0, I less than k, we need to check whether numbers less than k, all the numbers are present or not. Okay, if we'll use binary search because okay, don't I have a snippet for binary search? Edit snippets. This is our for array, and this is for string. This is our m sort. Okay, we don't have a snippet for our binary search. I'll just create one binary search. It needs to take an array, and it needs to take the key element. That's it, right? Shall we pass I and z also? Yeah, I initial and j for z, and we'll go for mid. calculating int mid and we have will equal to I plus j by 2. So let's calculate our mid. Now let's say if mid is equal to key, okay, a of mid is equal to key, then we'll say element font. So let's change the return type of our function to int. Else if a of mid is greater than key, that is return. Should I say return or should I just call the function? Well, I'll just call the binary search a comma key comma and if it is greater than mid plus 1 comma j. Else if a of mid is less than key, then binary search a comma key comma mid comma it is just I comma mid minus 1. If you write to return also, it doesn't, will that affect our code? Because you'll call this function, then we'll check the conditions, then again we'll call the other function. It will get automatically returned. Okay. So okay, for once let's check our binary search program. If binary search of I is not found is true, if it is found, we'll do nothing. If it is not found, then we'll say cout no, and we'll just break. Notice we are doing cout for twice. Or else shall we maintain a flag, and we'll make the flag is false, like comma if equal to it is always true, then we'll just make the flag to false. If equal to false, so that our code runs only once. If equal to false, if an element less than the binary search is found, we'll just break, and for now we'll just say found to check our binary search is working properly or not. So let's just compile. Everything is okay, right? Okay, something is wrong. Forgot that. Still something is wrong. Function for okay. We need to pass the array. Okay, function call is wrong. Array and the key is I, and the mid is 0 and n is the size. Line number 10. What happened in the line number 10? Yeah, it's int. Okay, we need to have returns in this also. Control reaches end of non-void function. Control reaches end of non-void function. What is this error? Here we are returning int, so like, or else we need to return 0, and then yeah, it's like element not found, right? So return 0. So we are testing, so we'll give 1, let's give 542 for now, which is m and k. 4 is m and k is 2. 4 is m. Okay, this condition is not correct, so it will not happen. Now the array I'm going to give is 0 is found, right? So 0 1 2 3, so we need to get found. Segmentation fault. We are accessing something but that we shouldn't access. What is it? It is n minus 1. Let's compile, and we got 1 5 4 2 0 1 2 3 4. Still segmentation fault. Keys I int is 0. So what is wrong in the binary search? Okay, we'll just convert our code from recursive to it doesn't actually, it is correct in recursive also. Okay, we'll just say else else it will be 0. We'll also say if if I is okay, I forgot this line. If I is greater than h, we need to return 0, right? Return 0, and that's it. Let's just run now. Now we won't get segmentation fault. Okay, we have wasted a lot of time in just creating this. Okay, why is our binary search not working properly? We need to get output 0 element found less than case 2, right? So 0 found, 1 found. Why are we not getting this? If key is equals to mail, we'll return the 1 because we found it. And if key is if key is less than, we are going in reverse direction. This should be, let's just say if key is greater than mid. That's the problem in our code. Found, yeah, we got found. Okay, now our binary search is working properly. Now we can go ahead and remove this. We'll break and we'll say f is equal to 0. At the end of the day we'll say yes. If then we'll say else. See out no, right? It can be no also. We'll say see out yes. I guess we have completed two cases. If an element is if an element less than the our k is not found in the given array, then we'll just simply say it's not possible, because there is a minimum number that's not in the array and we cannot include it in the array, so that max will be something like that. Cannot be anything that is greater than the missing element. Okay, now we need to go for this test case, I guess, because if we remove our k element from the array, we'll do it in n. My idea is to let's just make element n to -1 and just count, like int count equal to 0 for int I equal to 0, I less than n, I plus plus, and I'll say if a of I equal to k, then I'll make a of I equal to -1 and count increase. I need not make this, I'll just say count plus plus, count plus plus for f. Now I'll say if count, okay, the thing is if you remove this 3, the size is getting 3, right? So like n minus count should be greater than or equal to the size we can select, that is m. If it is true, then we'll just say of equal to 1, or we can just take this thing, cut it, and we'll say and now I guess that's it, right? Here, let's compile, hope this works. Yes, no, and yes. We got only 5 outputs for 6 inputs. Okay, we need to check which output we just missed. 1 5 4 2 0 1 3 0 3. We got yes. 1 2 1 2 0 and 1. If for this case we are not getting no. Why are we not getting no? Why is there no output? Okay, what should happen here? Since is k is equal, okay, let's just try run our code with this test case. Now we have n as 2, m as 1, k is 2. We are reading 0 and 1. Now k is greater than m, right? This is k, 2 is greater than m, so f should be equal to 0 and we are returning. Okay, we should not return actually. F equal to 0, that's it. We'll just say f equal to 0. We should not, I will break here. One, two, 1 2 0 and 1. Yes, we got our no there. Submit. Actually we can write directly, where is the if here, right? we can directly write as we can just print no and we can return it, but we are not. Okay, our answer is correct, and this is how we solved it. I'll just create a snippet for this. Okay, I'll do it off screen because we shouldn't waste our time solving questions. Let's close this. KMX is done. We'll go for highest frequency. Let's close even that. Let's get this here out. High freq.cpp. Okay, let's see the question. Chef has an array of length n. Let f of a denote the let f of a denote the maximum frequency of any element present in the array. For example, if a is equals to 1 2 3 2 2 and 1, then f of a is 3, which is the highest frequency, since element 2 is the highest frequency. And if there is given it's 2, since highest frequency of any element is 2. Okay, chef can perform the following operations at most once. Choose any subsequences of the array such that every element of S is the same. Say x, then choose an array integer y and replace every element in the subsequence with y. For example, let a is equals to an array. A few examples of the operation that chef can perform are: he can choose 2 2 and he'll change it to 5 5, and he will change next and he'll change it and determine the minimum possible value of f of a chef can get by performing the given operations at most once. The first line of input. Okay, he's trying to reduce the f of a, he's trying to reduce the frequency of elements. And we need to determine minimum possible value of f of a chef can get. Okay, the first line of input will contain a single integer t, denoting the number of test cases. Each test case consists of 2 input lines, n denoting the length of array a, and space separated integers. So it's again an array question. So we got our array snippet. For each test case, output the minimum value of f of a chef can get if he performs the operation optimally. He can select 2 and so output will be 2. He can select all these 4 elements and he can change them to 2. Then the f of a is 1. Okay, highest frequency is f of a, sorry. So this frequency is 5, right? Okay, this is slightly misleading because here he is increasing the f of a. We need to actually decrease the f of a. That's a tricky question right there, a tricky example right there. So he's taking 1 2 1 2 and let's take consider 2 and 2. The frequency will be 3. Let's consider 1, and if we change 1 to any other number, let's say 0 or let's say 10, I mean 1 space 2 space 1 space 2, I can change this number to 10 to 1 2. He can select any number and he can change it. That means for every element he can choose any subsequence of S such that every element of S is the same. Say x, then choose any integer y and replace every element in the subsequence with y. Yeah, I can change it this, then he'll just change it, then he'll change it to 12 and he will be 1. Now the his frequency is 1, right? But he's given 2. Okay, let's see. Chef cannot reduce by performing any operations. Didn't he reduce it to 1 here? Anyways, let's just go here. Let's just see the test case 2. 5 and he gave 5 elements here. 5 times 1. So now we can select all these elements and convert them into 4. So it will be like 4, 4, 4, 4, 4. The highest frequency is 4. Now we can select these 3, next the x2 and next one element, then the highest. F of A is the maximum frequency of any element present in the array. Okay, maximum so, okay, we need to maximize it, right? Maybe I'm seeing the question wrong. 1 to 1 2. Here the frequency of 1 is 2. 1 frequency is 2 and 2 frequencies also 2. We need to maximize the frequency. Sorry, that's it, right? So we'll select 1 and 1 and we'll change it to 2. Then the array will become 2 2. Sorry, 2 2. Now the frequency is 4. Frequency of 2 is 4. Frequency of 1 is 0. The maximum frequency of any element present in the okay. If you select any element, its frequency should be 2. Okay, fine. Now I get the question. I was missing that. I was just going for the highest frequency. Okay, no matter which element you select, its frequency should be 2. Okay. Now if Jeff can perform the operation, then the value of f of a in this case is 3, which is the minimum possible. Okay, he said minimum possible value of f of a. 3 since element 2 has the highest frequency equal to 3. For the maximum frequency of any element present in the array. Okay, once frequency is 2, which is less than 3, and 3's frequency is 1, which is less than 3 again. Okay. Now here it is given in this way, and if you change element, now its maximum frequency is 5. We need to reduce it to some number. Okay, now we have 1 1 1 1 1. In the explanation they are saying we'll change numbers to 2. Actually it's reverse. We'll reduce these numbers in this way. Okay, we still have 20 minutes. I guess we can solve it. 2 1 2 1 2. Now the maximum frequency has been reduced to 3, from 5 to 3. Very good. Can we reduce it to furthermore? If we select 2 and 2 here and convert into 3 3, so 2 1 2 1, okay, 3 1 3. Now the maximum frequency is 2, right? Which is the minimum possible maximum frequency. That is the minimum possible f of a. By how many times you can perform? At most once. Okay, the operation can be performed only once. Okay. only once. Now we have 1 2 2 1 2 2. Okay, 1 2 2 1 1 2 2. Now one's frequency is 2 and 2's frequency is 4. I can guess reduce this to, we'll select this any two numbers. And we'll reduce them to, right now the maximum frequency is 4. If we select 3 numbers and then it will be 3. So we'll just change this to 4. So 1 2 2 1 4 4. Now 2's maximum frequency is 2 and 4's maximum frequency is 2, sorry. So the answer is 2. Very good. So now we need to find a way to reduce the maximum frequency of elements. It's like, can we do in this way? We'll find the frequency of all the elements, and then we'll take the frequency of the highest element and the second highest element. Then if we perform the operation only once, the second highest member's frequency we can reach. That's it, right? Yeah. What if the element has only one element? If the size of array is only one, only one element is given, then highest frequency, the second frequency will be 0. Second highest frequency will be 0. So in this case we need to just reduce the highest frequency by half. 5 plus 1 by 2. I'm getting that's the solution. So I'm thinking is, let's maintain an vector of int a. It's not a frequency, right? And while reading itself, we'll say frequency of a of I will increase the frequency. Can we do this? Frequency of a of I plus plus. I guess we cannot, because frequency of, we need to first push the element into it. I couldn't remember the syntax. Frequency of, actually if it's a map you can do in this way, but here since it's not a map, it's just a vector, a of I guess you cannot do this in this way. Let's just remove it. Let me try to remember how can we change it. We can just I guess we can, a of I is a number, so if it's a number, okay, let's just put it in that way. If we get I couldn't remember it properly. or we can just say size here. We'll take n plus 1 size and we'll just initialize it with all elements with 0. In that way we can do this here. We got the frequency of elements. We'll sort the vector now. Sort a comma a plus n plus 1. We'll sort it. We'll find the, it's not a actually, it's freak. Now after finding we need to get the highest different answer equal to second highest frequency. That's it. Freak n minus 1 if answer equal to 0, then see out freak n minus 1. If it is 0, then we need to say answer equal to, if answer is even, if it is even, then we'll just say freak of n minus 1. We need to get the last second element. Freak of n minus 1 by 2. Else we'll be saying frequency of in frequency element n minus 1 plus 1 by 2, that element. We'll just print the answer. If answer is not equal to 0, then we'll just print the answer. I guess we are printing the answer, so there is no else required. That's it. I would like to write all this in one line so that it looks simple. Maybe it looks complicated. Anyways, let's just clear, compile. What is the error we are getting? Okay, how to sort the array? How to sort a vector? C++. Do we have a sort function? Yeah, we have a sort function. Okay, it's v dot begin to v dot end. So frequency dot end, frequency dot begin. We need to use these things. Let's just clear, compile high, then run, and we got 101. We need to get 2, 3, 2, and we got 1, 0, and 1. Let's set 3, 4, 1, 2. Sorry. 3, not 3. I went only one test case. 1, 4, 1, 2, 1, 2. The answer is 1. Let's check why. Why is it happening in that way? So we are trying to dry run our code. Since we got our frequency array set a of I is 1, so I will be increased twice, and we are sorting it, so it will be 0, 2, and 2. If we sort it, aren't we losing the position of the element? Yeah, we shouldn't sort it. Okay, let's just see what is happening then. Okay, now we got highest frequency is 2, answer equal to 2, so it should be 2. Let's just print our for int I equal to 0, I less than n, I plus plus sorry, I plus plus if we increase it, print frequency of let's just check n plus 1, compile 1 4 1 2 1 2. Okay, this is C out, I forgot C out. Let's just give some space, and also let's give a new line. Let's clear the screen. Okay, where am I typing? I guess my terminal got stuck. Let's open a new one again, and let's just say it's G++, compile, and 1 4 1 1 or 2 2, it doesn't matter. So we got 0 0 0 and 2 2. So frequency of n minus 2 will be, okay, frequency array size is n plus 1, right? So we can just access the nth element, and this is n, and this is also n. Second highest element we need to take, so n minus 1. Sorry, here n plus 1 is the size, that is 5 is the size, 3 4 5, 0 1 2 3 4 is the, okay, we are accessing 4, this is the last element. So this is the if it is 5 minus 3 3, so 0 1 2 3, second last element. N is 4, n is 4, right? 4 minus, okay, this should be just 1, I'm so sorry. Now we'll take the last element by 2, last element plus 1 by 2 if it is false. If answer equal to 0, then itself we will write, we'll run this code. Four 1 1 2 2, now we got 2. Okay, clear, copy this, and let's just run and paste. We got 2 2 2. For this test case, why is it 2? And let's just stop printing this, and let's print our answer. It's one test case with the 5 1 2 3 4 and 5. Okay, let's just increase its size. We got 2 as answer. I forgot to compile. 1 5 1 1 1 1 1. We got 0 and 2. 5 plus 1 is answer is divided by 2. Right now answer is, this is not the answer, it this should be fric off, and if the frequency element is we are speaking about a frequency element, not the answer. So now high frequency. Now we are running this, and we'll take all the test cases. 232. For all the given sample test cases, we are getting correct answer. Currently running test case 0. Currently running test case 6. And we got the wrong answer. What are we missing here? We are reading the input. And then we are calculating its frequency. Then okay, let's just give some random input values to check to find out the test case at which we are failing. Okay, let's run our code. Value 1, the size of array is 5. If we give 1 1 2 2 3, answer should be 2. Yeah, it's okay. And if we give 1 2 3 3 2 1, answer should be 2. 1, size of the array is 6. 1 2 3 3 2 1 are the elements, and the answer is 2. Let's check for the first question. That 1 2 3 2 2 1, answer is 2. We are reducing the f of a. It's correct. We are actually failing in some edge test case, and let's run one more time. Let's think of few values. What about the size is 10, and you have elements 1 for once, 2 for twice, 3 for thrice, 4 for 4 times, 5 for 5 times. Okay, did we it's because of the side key arrow. I want to check this is 1 2 3 4 5 6 7 8 9 10. Okay, now the size is 3, but you actually can select all this element. Okay, then it will be, what if I select 3 and 2 of these numbers? No, you cannot do that. What if I select 3 and 1 of this number? It will be 3 only size. So what is the test case I'm feeling here? Okay, we'll try solving this question even tomorrow. It's quite little disappointing because I thought we are because we just solved only one question for today in 1 hour, so that is disappointing actually. No problem. Well, so we actually almost solved this question because our sample test cases are winning. Okay, that's it for today, and let's what we have solved. Okay, we actually solved K-max also, right? K-max is the only sum we solve. High frequency we are trying to solve. For a second I thought I have solved two questions right there. Anyways,